Hello and welcome to the Global Electronics Report. It's Friday, October 14th and my name is David Burford. This month's Walter Custer column in Global SMT and Packaging magazine is reporting a slight uptick in September orders, coming out of a fairly flat summer season. Custer states the global electronics industry, with the exception of South Korea, is in slow growth but improving mode and predicts the increase in manufacturing orders will continue through the end of the year at least. No doubt the downturn in South Korean numbers must have something to do with the massive global recall of Samsung Note 7 phones. The company was in the news again this week with stories about its return kit, which comes complete with gloves, a protective pouch and 3 layers of packaging. Phones are not allowed to be shipped by air and have to be returned by road. Failure analysis expert Jerry Rigg provided an excellent teardown and explanation of the likely causes of the exploding batteries, which went viral. Here is an excerpt.
Rechargeable lithium-ion batteries are everywhere. Electronics, tablets, laptops, cars, and pretty much every single cell phone. And most of the time these lithium batteries are incredibly safe, as long as the lithium fail-safes are in place. Fail-safes that work. Samsung just voluntarily recalled an estimated 2 million Galaxy Note 7s as a safety precaution, since some of the batteries are exploding inside of the phone. Obviously, random explosions are not a feature that most people look for when purchasing a cell phone.
Global SMT and Packaging hosted a webinar yesterday on design for cleaning and reliability. Dr. Mike Bixenman and a panel of experts from Kester, Plexus and SDI discussed a wide range of cleaning-related topics and strategies for improving reliability in PCB assemblies. A recording of this highly technical, interactive debate can be found on globalsmt.net/recorded webinars. Rizan Ahmed, VP of Engineering and Technology at Dialight Corporation, released an article this week on the 6 critical factors for LED reliability. Trevor Galbraith spoke to Rizan about his article and LED reliability.
LEDs are probably one of the biggest lies in the electronics industry, in as much that retailers are constantly promoting these lamps with 100,000 hours life expectancy. But the truth of the matter is, as we all know, the solid state electronics behind these lamps very often falls over at 25,000 hours. What can we do? What causes this failure, first of all?
Yeah, I think that in order to find the answer that what goes wrong with the LED product, we need to look into that whether the LED products are designed with the fully integrated design technique in mind or not. So for example, if a company buys off-the-shelf LED power supply and buy the LEDs from someone else and put them together, and when they try to get the optimized result, they are not going to get the optimized results. And because the drivers have different life expectancy, it was tested under different conditions. The data that they get from the LED drivers is what they are only relying upon. So the answer to your question is that we need to look into whether the design was actually with the integrated design technique in mind or not.
Trevor went on to ask Rizan what other key areas to look out for.
Then the other factors are that if we go deep and we look into each component of the LED product, there are LEDs. Someone needs to make sure that the LEDs that they are getting actually have a reliable data behind them. And that's why we say that always look for LM80 data, or also pay very special attentions on the TM21 calculations. So if the LEDs are bought with no reliable data behind them, no matter who is going to put them in the product, the end result will not be reliable.
LM80 data refers to the hardness of the minimum housings, and TM21 data is the Energy Star luminaire specification, which was updated in June. Power supplies are a critical part of LED luminaires. Trevor asked Rizan how they affect the LED assembly.
Power supplies are drivers, which people buy off the shelf. What components they are using on those drivers? We all know that there are weak components on the power supply, such as electrolytic capacitors. They are very sensitive to temperature, and if the product is deployed in a environment where the temperature is high, they are going to degrade very quickly.
Trevor suggested to Rizan that the large cooling fins at the back of the LED assemblies were a crude form of thermal management. He asked how important is the enclosure design?
So component selections for your product also pay very special attention on that. Similarly, the casting, the enclosure, they also need to be rugged. You can have the best in quality LED, you can have best in quality power supply, but when you are putting them in the enclosure, enclosures do not withstand the harsh environment. The same result, you do not have a very reliable product which is going to stay there for a longer period of time.
You can watch the full interview on our Global LEDs OLEDs website. European Circuits announced that it is sponsoring the Imperial College Robotics Society's Eurobot entry for 2016-17. European Circuits marketing manager Neil Johnston said they hope the initial sponsorship may be the beginning of a longer-term relationship with the Imperial College Robotics Society. Tom Hartley, chairman of the society, stated that they are grateful to European Circuits for their generous sponsorship and that their support will allow engagement with more students through both the Eurobot team and at earlier levels of education through the outreach programme. Founded in 1998, Eurobot is an international robotics contest open to teams of young people, encouraging students to construct a fully autonomous robot from scratch to complete a series of challenges. That's it for this week. Check back next week for more top stories from around the electronics world.